Now let's focus on significance tests for the difference. So our hypothesized value is 0, that there is no difference between the two. Our conditions are the same as before. Now, filling in the information for your test statistic, or your critical value t, you have x bar diff and then your standard error of your group. So research designed an experiment to study the effects of caffeine withdrawal. They recruited 11 volunteers who were diagnosed as being caffeine dependent to serve as subjects. Each subject was barred from coffee, colas, and other substances with caffeine for the duration of the experiment. During one 2-day period, subjects took capsules containing their normal caffeine intake. During another 2-day period, they took placebo capsules. The order in which subjects took caffeine and the placebo was randomized. At the end of the 2-day period, a test for depression was given to all 11 subjects. Researchers wanted to know whether being deprived of caffeine would lead to an increase in depression. The table displays data on the subjects' depression test scores. High scores show more symptoms of depression. So do the data provide convincing evidence at the alpha is 0.05 significance level that caffeine withdrawal increases depression score on average for subjects like the ones in this experiment? So our null hypothesis is that mu sub diff is 0, and the alternative is that it's greater than 0, because it's talking about withdrawal increases depression, where mu sub diff is the true mean difference, placebo minus caffeine, in depression test score for subjects like these. Because no significance level is given, we do alpha as 0.05. So we're doing a paired t-test for mu sub diff. So it's random. They randomly assign them to the treatments, whether it's placebo and then caffeine or caffeine then placebo. The sample size is small, but the histogram of the data, remember we're looking at the difference, placebo minus caffeine. Notice that the difference is not given. There's not that extra row. That would be something you would have to calculate. So even though the sample size is small, your histogram here doesn't show any strong skewness or outliers. So mu sub diff is 7.364, standard deviation diff is 6.918, and we have 11 in our sample. So by hand, we get a test statistic of 3.53 and degrees of freedom of 10. So using our table, we get a p-value between 0.0025 and 0.005. Using your calculator, we're going to get a p-value of 0.0027. So because the p-value of 0.0027 is less than alpha, we reject the null hypothesis. We have convincing evidence that the caffeine withdrawal increases depression test score, on average, for subjects like the ones in this experiment.